catalyst reduction is an exhaust gas aftertreatment system used to reduce oxides of nitrogen, or NOx, produced during combustion. Using this technology, the chemical reaction of reduction is selective. This means that out of all the exhaust gas pollutants produced, only the NOx are specifically targeted and reduced. To achieve this, a reducing agent is injected into the exhaust gas flow upstream of the NOx catalyst. The agent more commonly used is known as aqueous urea. During the chemical reaction, the urea breaks down the NOx compound and then combines with these new elements to form nitrogen and water. The addition of SCR to an engine already fitted with NOx control devices may seem like overkill, but this is the manufacturer's response to tighter worldwide emission standards. Reducing agents require ammonia to break down the oxides of nitrogen. Although, due to ammonia's extremely toxic nature, the agent used in SCR systems is less pure. A common brand of aqueous urea reductant is AdBlue. This is a synthetically manufactured reductant using a 32.5% solution of urea in water. Urea-based reductants must be kept within a very narrow temperature range, as most will freeze if their temperatures drop below around -10 degrees Celsius. Likewise, these same reductants break down at temperatures of over 70 degrees Celsius and are susceptible to bacteria growth. Vehicles using SCR must have a storage system that can encompass the characteristics of urea-based reductants. To gain a better understanding of how the SCR system works, we need to be familiar with each component and their operation. The reducing agent or reductant tank contains a delivery module, level evaluation unit, and the heater control module. Due to the low freezing point of the reductant, heating elements are built into the tank, delivery module, and delivery lines to prevent solidification of the urea solution. Located in the reductant pump, heater pot, suction lance, and delivery line, these heating elements are operated by a dedicated control module. Information such as ambient air and engine temperature are supplied to the module by the engine control unit. The temperature of the stored reductant is supplied to the heater control module by a temperature sensor mounted to the delivery module. The reductant is drawn from a heated pot via a suction lance and filter. The pump used in this model is a diaphragm type, driven by a brushless motor, but controlled by the vehicle's engine control module. When the ignition is switched on and the operating conditions for the SCR system are met, the pump delivers reductant to the injector at pressures in this type of system to around 5 bar, or roughly 70 psi. When the engine is switched off, the ECM commands the pump reversing valves to operate, drawing the reductant out of the delivery line and back into the storage tank. This feature is vital for the correct operation of the system. If the reductant were to freeze in the lines or injector, not only would the NOx output of the engine exceed emission standards, but the expansion of the urea solution may cause permanent damage to the system. The sensor used for monitoring the reductant pressure is attached to the delivery module. The ECM monitors this analog voltage signal, determining the optimal current supply to the reductant pump. The ECM will regulate this current, which is supplied to the pump in the form of a PWM control, to maintain a predefined reductant delivery rate. The level sender unit used in the reductant tank is designed as a multi-sensor array and is mounted directly into the heater pot. A designated control module for this sender evaluates the level signals from each sensor and transmits actual level data to the engine control module via PWM signal. The individual sensors used in the tank are of the capacitive design and are calibrated to measure different properties of the reducing agent as well as the fluid level. Because the urea solution is of a dielectric nature, contamination, biological growth, reductant breakdown, and reductant quality can be determined by the capacitance of the fluid. Determining these variables is a legal requirement under Euro 5 emission standards. A condition of these standards is to prevent repeated engine starts if the reductant level is inadequate or the fluid quality is poor. The role of the injector is to deliver a metered quantity of reductant directly into the exhaust gases downstream of the close-coupled DPF, but before the NOx catalyst. Depending on the manufacturer of the SCR system, the injector pintle may be held open continuously during high engine NOx production phases, or it may be duty cycle controlled, influencing the quantity of reductant injected. The ECM is responsible for the operation and monitoring of the SCR injector and its control circuit. If a failure occurs in the injector or control circuits and reductant is unable to be introduced into the exhaust gas, the ECM may prevent engine start if the failure warnings are repeatedly ignored. A mechanical mixer is placed directly downstream from the reductant injector. The mixer functions primarily as an impact surface for the injected urea droplets. The reductant droplets are reduced in size on impact with the surface of the mixer. This allows the reducing agent to evaporate and mix into the exhaust gas faster. It also prevents larger spray droplets from impacting directly onto the NOx catalyst. The geometry of the mixer blades causes a swirling effect to the exhaust gas flow. This promotes an even distribution of the reductant stream. Shortly after the mixing stage has occurred, the aqueous urea solution undergoes its first reaction with the exhaust gas. This stage is called thermolysis. Thermolysis is a chemical reaction in which an initial substance is broken down into several chemicals by means of heating. This reaction occurs as the water contained in the aqueous urea boils off due to the exhaust gas temperature. The remaining compound separates into ammonia and isocyanic acid. The second stage of the first chemical reaction is known as hydrolysis. Hydrolysis is the cleavage of a chemical compound via its reaction with water. The isocyanic acid reacts with the water vapour to create additional ammonia and carbon dioxide. NOx reduction takes place in the reduction catalytic converter. This is where the NOx give up their oxygen molecules during the reduction process. It's the reaction between the NOx and ammonia that forms nitrogen and water. The design of the reduction catalytic converter is very similar to that of an oxidation catalytic converter, using a honeycomb-shaped ceramic body. The reduction converter's substrate is coated with a copper zeolite. This coating accelerates the speed of the NOx reduction process. The normal operating temperature of a typical reduction converter is just on 200 degrees Celsius. If the exhaust temperature drops below this, the chemical reaction is no longer effective, so reduction of the NOx can't occur. Exhaust gas temperature sensors located up and downstream of the reduction catalyst monitor and report changes in temperature to the engine control module. The NOx sensor is mounted in the exhaust flow directly downstream of the reduction converter. This sensor is similar in operation to a wideband or lambda probe, except 2 pump cells and sensing chambers are used. The sensor is maintained at a fixed operating temperature using a ceramic heater. The monitoring of NOx gases occurs in the second chamber of the sensor. The current that flows between the 2 electrodes across the pumping chamber is proportional to the NOx present in the exhaust gas. Because the produced current values are very low, a NOx sensor module is located very close to the sensor itself. The module converts the current values to a network message, which is then received by the engine control module. Reducing agents have a limited life. It may be necessary to check the condition and serviceability of the urea solution regularly with a designated service tool. Diesel emission control is only going to get more complex as worldwide emission standards are tightened and enforced. Keep ahead of your customers' needs by learning about this rapidly evolving technology. Thanks for watching.